Welcome to this Sahara 4 exercise. In this exercise, we will do a first run of the simulator calculation and review the results that we get for the regression phase of the analysis. So, we will now go to our Sahara project, and once here we have our map window open, we will also use in this exercise the production window. So now I will auto configure here view auto configuration. So now we have our map window and the production window together in our project. So now let's create a new template here, and we will call this graph for simulator calculation. Now let's go to the simulator calculation options. Here we can do a quick review of the conditions that we defined in the previous exercise. As we discussed, we will use the segregated flow option for the calculation. We will do the calculation, or the results of the calculation will be stored in this scenario, in the SF scenario coming from segregated flow. The injection scenario that we will use in this opportunity is the history scenario. So we will just use the injection that is already reported for each well in each layer from the history scenario. The initial saturations will be defined coming from the layer region information. In this case, we have reviewed that we have the information stored in the layer level. All the data sources will come from the layers as well. So we have all the information that we need here in layers data, and here we see that we have the information of the limits of the saturations, the minimum oil saturation, the minimum water saturation, the mobility. We have the water frame data as well. Here we have the initial saturations as well. So all the information that we need for this segregated flow calculation is already defined inside here in layer data. So we will do the calculations for all the layers. We won't use any fill-up curve. The end of the calculation will be in 2047. And the calculation primaries, we will use the information at the well level. Here remember that you have a number of options you can choose here. If you have done your declines for primary, if they are stored at the well level, you can use this option here, and if you have them at the layer level, you have a number of options to how to decide what to do when the first flow elements start to appear here. In this case, you can either decide to terminate primary at the secondary start, or don't terminate it, or terminate primary only during the periods with secondary. So if for any reason a well that started with primary recovery, then switch to secondary recovery, but then for any reason the flow element stop existing in the middle, it will restart with the declination that was defined in primsim for that well, for that layer. And we won't use any response time curve as well. So those are the conditions that were defined in the previous exercise. We will now click on calculate. Here it will take some seconds here, and here we have our report, our result report. So we have some patterns that are incompatible. We can see here that, for example, the magenta formation doesn't have any information, so it's not going to perform any calculation. It's just going to default to the field level, and it's the same here for the 1C1 layer. It's going to default to magenta. Here we have some layers where we don't have any flow elements. That's, as we reviewed, that's expected. I mean, we know that there are some layers where we don't have any injection, so we don't have any flow element. Here we have some combinations of wells without any injection, which as well is expected. Here we have no pore volume. We have already reviewed this case previously. This is because we don't have any petrophysical data for porosity in this layer, in this well D6, and the nearby wells D50, D52 and D65. So this is expected as well. And then we could do the calculation for the rest of the project. So here with this report, we can check the different reasons why we couldn't perform the calculation. But in this instance, let's just consider this calculation as good enough, because we could calculate we could run the simulation most of the project, even if we have some alerts here. Let's just click on OK, and let's review what was calculated. So now we will prepare this template of the production window to check on what was calculated. So first, let's open the history template. Now we have it available here. Um, Here we should have it. We could use this one. Let's erase this lower graph here. So I will just maximize this window here. And here we have total liquid production, total oil production. We could also add now. Let's add the oil production, monthly production of the result scenario. In this case, the calculation scenario SF. So we want to check on the total oil produced at the. Let's click on the object level because we want to see the total of the whole project. So let's just select it at the object level, and here let's select total calendar day. So we have that to compare to, and liquid as well, calendar day. And then let's select the injection of the history scenario as well. Here, monthly production history and water, injected water at the object level as well. So we have calendar day. And now we will select all the wells. I will auto configure here just for a moment. And here we can see the results. Let's improve the colors a little bit. So let's change, for example, the color of the result of the simulation in oil. Let's change it to red, so we have a good point of comparison here. Let's change this oil to more clear green. This is the green curve is the oil of the history scenario, is the one we should compare to. And here in red we have the oil of the results of the simulation of the segregated flow. Here we also have water, sorry, liquid, total liquid. In this case, the one of the simulation, we will keep it. Let's use for injection, let's use something more distinctive, something like this magenta here, and let's, yes, we can see that we have injection here, but for now let's hide it. And here we can see the relationship between the liquid that was calculated and the one that was loaded from history. So the one in black is the one that is the data, the data that we know, this the hard data that comes from history, and the one on light blue is the one that has been calculated. So now we can see that the adjustment is not perfect. I mean, we can see that in this first stage we have something to improve here, but overall the fit for the liquid is quite good. So we see that once the secondary recovery started, the fit is quite, it fits quite nicely. So we have a good regression here overall for liquid. Then we see that if we maintain the same liquid production rate, assuming that also we will maintain the same injection over time, so this is going to be balanced, the oil is going to decrease like this over time. But here we can see that the oil adjustment is not as good. It could be better. We can see that it has some spikes here that are most like it's higher than expected mostly. And here we have that the calculation goes below the expected curve here. Obviously, these are analytical methods, so it isn't going to consider things like, for example, low productivity of the well for things that cannot be considered in an analytical model. For example, skin damage or things like that. So we may have other reasons why we have this. So for example, the wells might not be exploited correctly. They may have high submersions. You may need, for example, you may have a lot of wells that have sucking rod pumps and they need to have ESP, for example. So there are a lot of things that are not considered in an analytical model that might explain some of these differences. But when things like this happen, when you have a good fit with liquid, because that means that your flow elements and your coefficient distributions are fine, that they are probably correct, but your oil is it's not as well fitted as the liquid. You may need to review with the calculation method that that you're using. Maybe instead of using segregated flow, you may need to use, for example, the characteristic curve, the statistical curve, or the war method, or any other statistical method. So yeah, that will be everything for this tutorial. We have done a first approach here, we have run the first calculation, and we have checked on the results using the production window. In the next exercise, we will do more in detail analysis of the results with other tools that we have at our disposal, but that will be everything for this tutorial. Thank you for watching and have a great day.